Okay, geometry fans, our topic for today, this is kind of an introductory topic to Chapter 8. It's called Simplifying Radicals. This is something that you may have done in Algebra 1, so it could be a review for you. But this is a concept that we're going to be using with right triangles quite a bit, because we're going to have to simplify square roots. So a radical is just a square root. Before we start, let me tell you your joke of the day. Why can't your nose be 12 inches long? And the answer is because then it would be a foot. Nose, foot, different parts of the body. All right, to start off, we're going to look at two things. The first is called perfect squares. And this is a review. This is something that you've learned many times. A perfect square is what you get when you multiply a number by itself. So 1 squared, 1 raised to the second power is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. And I'm going to go down to 10, but I'm not going to write it out every time. So 5 squared, 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Now you can keep going. I would actually recommend, you're going to see some numbers come up all the time. 12 squared, for example, you will see that quite a bit. So it's to your benefit to know these. You should definitely memorize the first 10 perfect squares, but I would go up to the first 20. And when you start getting into right triangles and Pythagorean theorem, you'll see why. It's just going to make things faster for you. So the perfect squares are these values here. 1, 4, 9, 16, 25, 36. Those are perfect. The reason they're called perfect squares is when this stuff was being discovered, these concepts were being written for the first time, the way that they looked at it, the way that mathematicians used to look at this was visually. When you look at the number 4, you can draw. If I use dots, I can draw a square with 4 dots. If I have 9, I can draw a square that is 3 rows and 3 columns. That's a perfect square. 16, 4, 4, 4, 4. So the idea of a perfect square is that I can take these numbers and I can organize them into an actual square. Now, the reverse of this process is what we call a square root. So a perfect square is what I get from multiplying a number by itself. A square root is if I take the square root of 1, what was the number that I had to multiply by itself? It was 1. The square root of 4, what was the number that I started with to multiply to get to 4? It was 2. The square root of 9 is 3. 16, the square root of that is 4. The square root of 25 is 5. So like the root is kind of like the beginning, if you think of the root of a tree. The root of these numbers is whatever we started with to multiply. And again, I'll go up to 10 here. Square root of 49 is 7. Square root 64 is 8. 81 is 9. The square root of 100 is 10. You can keep going. Okay. Now, what we're talking about, though, the main topic is simplify radicals. A radical symbol is basically this symbol right here. Now, when you get into Algebra 2, this is for a square root, but you can also have a cube root, a fourth root. These are all radicals. Okay, for us, we're only going to be using square roots. The idea to simplify a radical basically means to pull out all perfect square factors. Pull out all perfect square factors. Now I'm going to show you 2 ways to do this. One way is kind of systematic, it's very step by step, and then one way is going to be faster. If we want to simplify, so here's number 1, simplify the square root of 18. Now that is not perfect. I cannot draw a square with 18 dots. I can make a rectangle, but there is no number times itself that gives me 18. However, what I'm going to do is I'm going to break this down into what I call a factor tree. A factor tree is basically using multiplication. I'm thinking, what multiplies to 18? Now, I could say 2 and 9. Now, here's the thing, though. 2 is what we call a prime number. I can't break that down anymore. I could say that's 2 times 1, but then I'm just repeating the 2. So I'm going to circle that because I'm done with 2. When I get down to a prime number, which is only divisible by itself in 1, that's finished. Now, the number 9, though, I can write that as 3 times 3. Those are also prime numbers. Now, what I'm going to do is I'm going to rewrite the square root of 18 as 2 times 3 times 3. This is what we call a product of primes. A product of primes is multiplication of prime numbers. 2 times 3 is 6. 6 times 3 is 18. So this is really the square root of 18. I'm just writing it in a different way. So these are equal, they just look different. Now, to simplify radicals means to pull out all the perfect square factors. Well, what does it mean to be a perfect square? That's where you multiply a number by itself. Okay, 3 squared is 3 times 3. 4 squared is 4 times 4. So what I'm looking for with my primes is, do I have a pair of numbers that are the same? A number times itself, I do. That's the 3 times 3, that's really equal to 9. So what I can do, since that's the square root of 9, well, I'm going to pull that out because the square root of 9 is really 3. So I'm going to pull out the pair. Now, it's not 3 times 3. When I pull out the pair of numbers, it's just 1, 3. Because that's really equal to 9. The square root of 9 is not 9, it is 3. Now, notice the 2 is left. I can't pull that out because there's not another 2. That's not a perfect square. So my answer, basically we're done here. We're going to write it one more time, and we're going to say that's 3 square root 2. Okay, now I'm going to get a calculator. And let's see that this is really the same. If we do the square root of 18, that's the original problem, we get, oh, it actually says 3 square root 2. It does it for me. Oh, that's awesome. As a decimal, we get 4.24. If I type 3 square root 2, we get the same decimal. So what happens here, again, these are equal expressions. 3 square root 2 is the same as the square root of 18. It's just this is simplified. Okay, let's take another example. Let's do the square root of 75. All right, so the first thing we're going to do is break it down. Let's see, I know that 5 goes into that, 5 times 15. When you're doing the factor tree, you're breaking this down with multiplication division. 5 is prime, I'm going to circle that. 15 is 3 times 5. So these are all the prime numbers, so we're going to stop there. We're going to rewrite this. I'm going to put the 5s first this time. 5 times 5 times 3. Now, is that still 75? If you're not sure, you can always just multiply that. It should be the same thing, it is. So that's 75. Now what we're looking for is perfect square factors. A perfect square is a number times itself. So if I see a pair that's the same, I do. I'm going to pull out that pair, write it down one time. Now whatever's left under the square root is going to stay. So our final answer is 5 square root 3. A factor tree is always going to work. However, that's not always the best way. If I take the square root of 75, when I look at this number 75, if I look at my perfect squares, you might notice, wait a minute, 25 goes into that. So what I could have done is say, look, instead of going through the tree, I know that 25 times 3 is equal to 75. If I recognize, hey, 25 is perfect, I don't need to break it down. I can immediately simplify that. Let me pull that out. The square root of 25 is 5. And look at what I have, 5 square root 3. So that would be the fast way. The fast way would be to recognize certain numbers that are factors. Okay, if I can break it into a perfect square as a factor, then I can do this much more quickly. For square root of 18, well, how about 9 as a factor? How about we write that as 9 times 2? What's the square root of 9? Well, it's 3. Let me pull that out. 2 is going to stay, and I get 3 square root 2. Okay, so it's really two ways to do it. I prefer to know these and to know that those divide into certain values. But if you're not sure, you can always break it down into the primes. So let's do a few more examples here. Let's take number 3. Let's do the 7 times the square root of 80. So let's say we have a number on the outside already. I am going to ignore that for now. I'm going to take the number 80. Let's do a tree here. 8 times 10. Now 8 is 2 times 4. 2 is prime. 4 is 2 times 2. Okay, so now this part is done. These branches are done. 10 is 2 times 5. Now when we rewrite this, we have 4 2's and a 5. So that is 2 times 2 times 2 times 2 times 5. And we already have the 7 out there. I'm going to rewrite that. When I see a pair of numbers, that's a perfect square. That's 4. The square root of 4 is 2. But then there's another pair of 2's, so I have to pull that out as well. The square root of 4 is 2. Now, anything that I pull out, those will get multiplied together. So 2 times 7, that would be 4 times 7. What we get is 28 square root 5. That is simplified because the 5, there's no perfect square factor of 5. If I had looked at 80, now this is where you have to be careful if you try to use the faster method. 4 goes into 80, but so does 16. I always want the biggest perfect square factor. So what I would do is write this. I had the 7 on the outside. 80 is 16 times 5. What's the square root of 16? 4. So I'm going to take the square root of that. What's 4 times 7? 28. And what's left? 5. Okay, let's do a few more here. I'm going to flip it over. Example number 4. The square root of 108. Now the fast way is to look at your perfect square numbers. 4, 9, 16, 25. 36 actually goes into 108. 36 times 3. What's the square root of 36? 6. So the answer is 6 square root 3. But if I make a tree, this is an even number, so I could always divide by 2. 2 times 54. 9 goes in 9 times 6. 9 is 3 times 3. Be careful with 6. That is 3 times 2. It's not 3 and 3, because I'm not adding to get to this, I'm multiplying. Now, let's see, square root. We have 3 3's. We have 2 2's. I have to make sure I write all of these down. We're looking for pairs. Here's a pair of 3's. That's really 9. The square root of 9 is 3. Here's a pair of 2's. That's 4. The square root of 4 is 2. 2 times 3 is 6. That's the outside. Okay, what's left underneath? 3. All right, let's do one more here. Let's take the square root of 500. Now, if you can think, what's the biggest perfect square factor of 500? Well, how about 100? How about we look at that as the square root of 100 times 5? What's the square root of 100? It's 10. So the answer is 10 square root 5. You see how much faster that is than if we try to go through here. You can take 10 times 50, 2 times 5, those are prime, 5 times 10, that's prime, 2 times 5, that's prime, 5, 5, 5, 2, 2, it's all multiplying, that's 500. Okay, this is really 25, that pair. Square root of 25 is 5. 2 times 2 is 4. The square root of 4 is 2. Multiply that, we get 10. And what's left is 5. Okay, so it's your choice when you're doing this, but I think it's always easier. If you can think of a perfect square factor, then that's what you want to do. And that is the end of the notes.